Welcome to Maths with EJD. In this video, we're still talking about statistics, and the topic here is hypothesis testing overview. So, I'll just go through all the nuances of hypothesis testing. And after this video, I'll take the popular test one after the other and, explain them with practical examples. So let's go. Of course, you want to subscribe to this channel. You also want to hit the notification bell so that you can always get notified each time a new video is released. And then don't forget to comment, like, and share. So hypothesis testing is what the focus is on today. And hypothesis testing is a method for making statistical inferences about a population from sample data. Okay. It begins by formulating two competing hypotheses, namely the null hypothesis, otherwise known as H naught, which suggests no effect or difference. And then you have the alternative hypothesis, that is H1, or you can call it HA, and this suggests there is an effect or difference. Okay. Now, let's talk about steps. Steps in hypothesis testing. So the first step is to formulate the hypothesis, like we've mentioned. Formulate the two hypotheses. Okay. Here, you define the null and alternative hypothesis. Simply, the null hypothesis is something like there is no difference between this and that, or there's no effect, of this particular thing has no effect. Whereas the null alternative hypothesis would be that there is a difference or there is an effect caused by this particular thing, usually. Number two is you want to select the significance level. Select the significance level, which is called alpha. The significance level, which is called alpha. Okay. Now, here you choose a significance level, and it is typically 0.05. So this significant level is 0.05. So this particular one, it corresponds with, we've talked about confidence level before. So confidence level plus significance level should be equal to 1. So this 0.05 corresponds with 95% confidence level. Confidence level. Okay. So that means that there's only a 5% chance that what you have said is going to be wrong. Only a 5% chance. So there's 95%, you're 95% confident that what you have, the position you are holding is true. So you can choose a significance level, which is typically 0.05, and that corresponds with 95% confidence level. Or another popular one is 0.01. Of course, that corresponds with 99%. That corresponds with 99% confidence level. So this is a higher confidence level. So the margin for error is smaller. It's only 0.01 compared to 0.05 in the other case. So formulate the hypothesis, select the significance level alpha, and just like I said, significance level plus confidence level is usually equal to 1. Okay. Really important. Sig uh, Significance level plus confidence level is usually equal to 1. That's why 0.05 plus 95%. 95% is more like 0.95. So if you add the two together, you get 1. Same for 0.01 and 99%, which is 0.99. So if you add the two together, you get 1. Okay. So we go to the third step. And the third step is to collect the data. Collect data. So what kind of data do you need for your analysis, for your testing? So here you just gather relevant sample. Gather relevant sample. In fact, most time before you start doing a test, you already have your data at hand, right? So the next point, step 4, is to choose a statistical test. Now, this is a big issue because you need to understand your data and then understand the kind of test you need to choose. So choose a statistical test. And this is going to take a bit of time because it's really important. In fact, I want to change colors at this point. So, and to choose a statistical test, right, there are two broad types of tests. So the first kind of test is what is known as the parametric tests. You have the parametric tests. So, and in parametric tests actually assume the data, whatever data you have, follows a specific distribution. Okay, it follows a specific distribution. So it means you know the distribution the data follows. So it follows a specific distribution, usually normal distribution. So if you are guaranteed that something follows a normal distribution, then you can use parametric tests. So parametric tests assume the data follows a specific distribution, usually normal. So, and common examples. So, common parametric tests. Common parametric tests include you have the Z test, or if you like, Z test. So you should know when to use each test, right? Z tests is used, it is used when the sample size is large. And just like we said the other time, so following the law of large, the central limit theorem, rather, we assume that a sample size is large enough once the sample size is greater than 30. Okay. Or apart from that, if it's either the sample size is large, that is n is greater than 30, or the population variance is known. So if you know the population variance, that's another condition for using a Z test. So the sample size is large, that is n greater than 30, or the population variance is known. I think this n should even be greater than or equal to 30. So 30 upwards, you can use Z test. Or the population variance is known. And again, the data is normally distributed. The data is normally distributed. Okay. So another point is that the z-test actually it compares the sample mean. It compares the sample mean to a known population. So if you have enough information about the population, you can do z-test. So it compares the sample mean to a known population mean, to a known population mean using a z-score, or what you can call a z-score. So z-score actually measures, which measures how many standard deviations, how many standard deviations the sample mean is from the population mean. Okay, so that is when you use z-test. The size is large enough, greater than or equal to 30. The variance of the population is known. Okay, now that's about z-tests. Let's go back. Let's talk about another test, which is t-test. For t-test, you can have one sample t-test, one sample t-test. Now, from subsequent videos, I'll be taking this test one after the other. So actually, I'll take actual examples to drive the point home. So this is just an overview of everything. So one sample t-test is similar, right? It's similar to the z-test, but it is used when the sample size is small. And of course, big sample size is 30 upwards, n greater than or equal to 30. So when the sample size is small, that's simply n less than 30. So if the sample size is less than 30, then you go for one sample t-test. So one sample t-test is just like z-test, except that it is for when the sample size is small, that is, the sample size is less than 30. And of course, if you don't know the population variance, and the population variance is unknown. Okay. So that's another test. Then we go for another test still under parametric. Another parametric test is what you can call the two sample t-test. Two sample t-test. Okay. So two sample t-test compares the means. It compares the means of two independent samples. So if you have two independent samples, then you can use a two sample t-test. Compare the means of two independent samples. Okay. Independent samples, of course, means the samples that don't have anything in common, so to speak. Then we have what you call the paired t-test. You have the paired t-test. Paired t-test. So for the paired t-test, right, it compares means from the same group, at different times. Same group, different times. Okay. So here, in the case of two sample t-test, you're taking two independent samples. But for paired t-test, you're talking about means from the same group taken at different times. Okay. So those are the four tests we will have under parametric test. That does not mean that that's all you have, right? Okay, that doesn't mean that's all there is about parametric tests, but those are the four I'll be focusing on. So next, let's talk about let's talk about non-parametric tests. Non-parametric tests. So you can see parametric test as number one. Then number two, talking about types of tests now, statistical test. Another set of tests would be the non-parametric tests. Non-parametric tests. So for non-parametric tests, right, they are used the data, when the data does not meet the assumptions, does not meet the assumptions of parametric tests. Okay. So e.g., the data is not is non so there's non-normal distribution. The data is not normally distributed, non-normal distribution. Another thing is when you have ordinal data, you remember all the measurement skills like ordinal, ratio, and all the rest. So you can use non-parametric test for ordinal data. Okay. Like maybe things like first position, second position, and things like that. Those are ordinal data. So you can use parametric test for ordinal data or even small sample size. Small sample size. Okay. So let's talk about some common non-parametric tests. Common non-parametric tests. So the first one would be the Mann-Whitney U-test. Mann-Whitney U-test. The Mann-Whitney U-test. So this actually compares two independent samples. Two independent samples. So then we have the Wilcoxon signed rank test. Signed rank test. Okay. So this compares two related samples. Compares two related samples. So, I mean, I'm going to make a video for each of the tests to actually clarify what all this means. So compares two related samples. Okay. Then we have the Kruskal-Wallis test. The Kruskal-Wallis test. The Kruskal-Wallis test compares three or more independent groups. Three or more independent groups. Compares three or more independent groups. Okay, that's the Kruskal-Wallis test. And lastly, we have a popular chi-square test. Chi-square tests. Okay, for the chi-square test, right? This actually tests relationships. It tests relationships between categorical variables. Between categorical variables. Categorical variables. So if you have categorical variables, you want to test the relationship between them, then you can use the chi-square test. So that's talking about the parametric test. So in choosing a test, a statistical test, you need to find out, is it parametric, is it not parametric, and what is the nature of the data before you can settle for a particular statistical test. Okay, so we go on with the steps, right? In hypothesis testing. Now it's step 5. Step 4 is about step 4 step 4 is about is to choose a statistical test. Now let's go for step 5. So once you use your statistical test, the next thing is to calculate the test statistic. Calculate the test statistic. So, I mean, these names look alike, but they actually mean different things. Statistical test is different from test statistic. Okay. So this now, depending on the test used, this this could be a Z score, a T score, a chi-square statistic, a chi-square statistic, and so on and so forth. So it all depends on the test you use here. So if you do Z test, you use a Z score. If you do T test, you use a T score. If you do a chi-square test, you use a chi-square statistic, and all that. Then, of course, to just drive a point home, right? If you do Z test, so we say for the Z test, the Z score is calculated, Z score is calculated as Z equals X bar minus mu divided by sigma all over square root of N. Okay, that is if you do the Z test and all this now, where X bar is the sample mean, X bar is the sample mean. Okay, normally it should even be like small x. Well, get the gist. So mu is the population mean. Of course, if you do Z test, it means you know the population. You have all the information about the population. So mu is the population mean. Then you have sigma, because the standard deviation is known, right, of the population. So you can use Z test. So sigma is the population standard deviation. Population standard deviation. Okay. And then you have N, which is simply the sample size. N is the sample size. Okay. So that goes. So you say that for large samples, for large samples, or known population variances. Of course, if you know the population variance, that means you know the population standard deviation. For known population variances, Z scores standardize, standardize data, making it easier to assess whether to reject H naught. Okay. So that is step 5 to calculate the test statistic. That's step 5. So step 6, is to determine the p-value. Determine the p-value. Okay. So determine the p-value. All right. So this is the probability. This is the probability of observing a test statistic, as extreme as the one calculated under the assumption under the assumption that H naught, which is the null hypothesis, is true. So for a Z test, the p-value is derived. So you have to get this from a table. The p-value is derived from the Z distribution. So it's derived from the Z distribution. Okay. So once you calculate the p-value, step 7 is to make a decision based on everything you have gathered, you have put together. So number 7 now, you have to make a decision. Make a decision. Okay. Make a decision. So one possible decision is that if the p-value is less than or equal to the significance level alpha, then you reject the null hypothesis. Reject the null hypothesis. Okay, reject the null hypothesis. That means you support the alternative. Support the alternative. Okay. So once the p-value is less than or equal to alpha, then another thing is that if the p-value is greater than the significance level alpha, then you fail to reject. You fail to reject the null hypothesis. You fail to reject the null hypothesis. That means the null hypothesis stands in that situation. Once the p-value, I think the p-value is related with the test statistic. So once that is greater than the confidence level, because you don't want to exceed the confidence level, right? So once the p-value is greater than that, so you fail to reject, you accept the null hypothesis. So after that, you can go to number 8, which is to draw a conclusion. Draw a conclusion. Okay. So, and that simply means to interpret the results, based on the test outcome. Based on the test outcome and the context of the study. Okay. Now, in doing all this, right, you have to be aware that there are possibilities of errors. So we get to talk about errors in hypothesis testing. Errors in hypothesis testing. Okay. So there are two types of errors, basically. That's the first one is the type 1 error. So that is called the alpha error. Type 1 error. And that is the a type 1 error is actually rejecting the null hypothesis, when it is true. Okay. So the null hypothesis is true, but you reject it. So it is called a false positive. A false positive. So if you reject something that is true, that's a false positive. So that's type 1 error. So reject the truth that you are committing type 1 error. Then another error is to failing to reject the null hypothesis when the alternative hypothesis is true. That is false negative. So type 2 error, also known as beta error. So here, that is you failing, that is failing to reject the null hypothesis, when the alternative hypothesis is true. When the alternative hypothesis is true, and that you call the false negative. False negative. So you can have false positive or false negative. Type 1 error, false positive. Type 2 error, false negative. So that's rejecting the truth and accepting the wrong. Okay, so those are the two types of errors we have for in hypothesis testing. So let's talk about confidence intervals and z-scores. Confidence intervals and z-scores. Okay, so a z-score, which we already saw how to compute the other time, a z-score can also be used to calculate confidence intervals. I think we used this under estimation, especially for interval estimates. A z-score can also be used to calculate confidence intervals for population means. Confidence intervals for population means. For example, a 95% confidence interval for a population mean based on a Z distribution is given by this. So confidence interval. Okay, let me write that specially. It's given by CI, confidence interval equals X bar plus or minus Z alpha over 2 multiplied by sigma over square root of n. So of course, this plus or minus is what gives you the interval. So when you subtract, you get the lower limit of the interval. When you add, you get the upper limit of the interval. So here, say where Z alpha over 2 corresponds to the critical value, from the standard normal distribution, So that typical value can be, for example, 1.96, usually 1.96 for a 95% confidence level. Okay. So that is the idea of confidence intervals on z-scores. We're going to come across all of this as we go on. So lastly, let's talk about applications of hypothesis testing, right? So see that hypothesis testing, including the use of z-scores, is applied in fields like quality control, clinical trials, social sciences, and finance to test population parameters. Test population parameters and validate claims. All right, so with this, we come to the end of this video. By integrating z-scores, we come to the end of this video, and be sure to subscribe to this channel so you can always be in the loop. And of course, hit the notification bell so you can always get alerted when a new video is released. And don't forget to comment, like, and share. Comment if you want me to teach a topic or you want me to solve a problem, then like and share so that more people can have access to this priceless knowledge. See you next time. Bye.